Okay, so today our learning objective, what we're going to be learning about, is something called product of prime factors. So can you write that down please in your book and underline it. Product of prime factors. So we're going to look at, we've already looked at factors. Okay, so we're going to look at some factors, but we're then going to take it one step further and we're going to look at prime factors because there is a difference. And then I'm going to show you how to find the prime factors of a big number. Now, later on, you'll be using that to help you find lowest common multiple and highest common factor, but that's not yet. We need to know how to do the skill bit first. Okay, so let's have a look at the number that we used this morning in mentals. So we all know the factors of that. Let's do 24. So write 24 for me, and then once you've done that, I'd like you to write the factors in ascending order for me like we did in mentals. So I'm going to do that in a different colour. So I've got 6, 8, 12, and 24. So they are the factors of 24. Okay? Do we all remember? We all agree? Because 1 times 24 is 24. 24 times 1 is 24. 2 times 12, 12 times 2, 3 times 8, 8 times 3, 4 times 6, 6 times 4. Okay, so there are 8 factors altogether. Using what you know about prime numbers, which of those factors would you say are prime factors? Great, lots of hands going up, excellent. Ashi?
3.
3 is a prime factor, well done. So let's circle that one. Bryce?
I was going to say 3, but then...
Oh, you're going to say 3 as well. Tyler?
2.
2, well done. Are there any other prime numbers in that list? No. 1 isn't a prime because we found that out in mentals, didn't we, Jack? So 1 doesn't count. 2 is a prime, it's the only even prime, well done. And then we've got 3. 4 is obviously composite because it divides by 2. 6 is composite, 8 is composite, 12 and 24 are composite. So these are your prime factors. Now, we also learned in the first week the word product, didn't we? What does product mean in the mathematical context? Bryce?
Times.
Multiply, well done, that's right. So, what I want you to do now, I'm going to give you 15 seconds. I want you to make 24. Okay, so the answer has got to be 24, but the only way you can make it is by using the prime factors and a multiplication sign. You can use as many multiplication signs as you need, and you can use 2 and 3 as many times as you need, but you need to make 24 just using those 2. Okay, 15 seconds, go. Got to pause it. Who would like to have a go at making 24 for me just using those numbers? Cameron?
Are we allowed to use the whole sign?
No, you have to only use multiplication.
What if it was
Blake?
2 times 3, 2 times 3, 2 times 3, then like 4.
No, you can't times it by 4 because 4's not a
Oh,
prime.
no, like...
But how could you make 4 using 2 or 3?
No, but it's like 2 times 3 repeated 4 times.
Oh, I see. Sorry, thank you. Yeah. So 2 times 3 times 2 times 3.
Yeah.
Right, is that correct? Let's have a look. 2 times 3 is 6. Times 2 is 12. Times 3 is 36. So what do I need to put there? Let's go through it again. 2 times 3 is 6. Times 2 is 12. Times what is 24? 2. Well done. Okay, so that is The product of the prime factors are 24. Now, we've also been learning about index numbers, haven't we? And that's fine, we can write it like that, but can anyone think of a neater way of writing it? Zach?
2 to the power of 3.
Times 3, that's right. Well done. Now, if you put 2 to the power of 3 times 3 into your calculator, you would get 24. Okay? So that is the two ways of writing it. You can write it in, what's this called? Begins with an E. Go on. Expanded notation. Get you. Well done. That's expanded notation. This one is index notation. Okay, so we're going to have another go with one. Right, what I want you to do now is using the factors, I want you to list, we did 30, let's do 30, but list them in ascending order this time. So what are my factors of 30? Do you want to have a go, Phoebe? Who'd like to have a go for me then? Go on then, Lachlan.
1, 2, 3, 5, 6, 10, 15 and 30.
Perfect. You see, and that is just an absolutely brilliant example of how getting something wrong the first time, make sure that you remember it the second, because you got it perfectly right this time. Good on you. Okay, so again, which ones are the primes? Mackenzie.
2, 3, 5.
Yes, there's a 5 this time, isn't there? So, okay, you've got 15 seconds to make 30 using 2, 3 and 5 and a multiplication sign. Okay, Bryce.
2 times 3 times 5.
2 times 3 times 5. Okay, so 2 times 3 is 6 times 5 is 30. Okay. Anyone do it in a different order? Mackenzie.
I did 2 times 5 times.
2 times 5 times 3. Okay, that also equals 30. Anyone do it in a different order? Caitlin.
Not in a different order, but 2 power 3 times
You did 2 times 3 times 5. No? 2 times...
5. 2 to the power.
Okay, so you did 2 to the power of something. So, okay, did it look like this? Right, okay. How would you write that in expanded notation?
Oh, it was in expanded notation.
No, if you did do it in expanded notation, it would look like that, wouldn't it? 2 times 2. Have you got 2 times 2 in there?
I said 2 times 3, 2 to the power of 3.
2 to the power of 3. Ah, right. Okay. 2 to the power of 3. Now, this is brilliant, actually, because this is a really good way. Sometimes the best maths comes out of a misunderstanding, because it means I can explain exactly what's going wrong. Now, 2 to the power 3, you would write it like that. Now, is that the same as that? No, it isn't, is it? So, 2 to the power 3 means 2 multiplied by itself 3 times. 2 times 3 is totally different. Okay? But thank you. I really appreciate that, because that's brilliant, because it means I bet other people have written that too. And they do. When I've marked it, definitely people have done that, so that's awesome. Okay, now then, the other way might be 5 times 3 times 2, or 5 times 2 times 3. Does it actually matter what order you do it in? Why not? Brooklyn.
Because multiplication is
What's that word? Can you remember? Go on then.
Commutative.
Commutative. Well done, because it means it can go either way, can't it? Okay. Right, let's pause. Thank you.